To find the shaded area of the square with the circle inside, we're first going to take the outside area, which is the square. So we're going to take 10 centimeters. We're going to square that. And then we're going to take away the inside area, which is the circular area here. I'm going to shade that in, it's yellow. And we're going to take away that area, so we're going to subtract the area of this circle. Well, that circle is going to have a radius of 5. So we're going to take pi r squared. So we're going to square 5 to get the square, and then we're going to take pi of that, which gives us the approximate area of that circle. And that works out to be 100 minus 25 pi centimeters squared. Now again, we can convert this into a decimal value. 100 minus 25 pi works out to be 21.46 centimeters squared, so which I'm going to round to 21.5 centimeters squared. Looking at D, what we can do is we can break this up into a trapezoid and a little rectangle here. But I'm just going to make this fairly simple, since if I don't know the formula for a trapezoid, I could just break this up into 3 different regions. Okay, I have my square area in here. I have my rectangular area here. And then I have my triangular area in here. And I can find those 3 areas separately. So I'm going to first find out the area of the square. So the area of the square is going to be a 5 square, so that's going to be 25 centimeters squared. The area of the rectangle, well, I need the height and the width of that rectangle. It's going to be 45 centimeters wide times 15 centimeters tall. Okay, so that's going to give us a total area of 675 centimeters squared. Okay, so lastly, I have the area of the triangle, and we need to know the width of this triangle. Okay, we know the total length is going to be 60. We have to take away a length of 5 and a length of 45. So we know that this length here is going to be 10 centimeters. We need to use a 90-degree height. So we're going to use a vertical height, which is 15 centimeters. So I'm going to get 10 centimeters times 15 centimeters. Because it's a triangle, I need to divide it by 2. Okay, and that is going to give me 75 centimeters squared. So then the total area of this, when I sum that all up, I'm going to get 25 plus 675 is 700, plus 75 is 775 centimeters squared as the total area. For the cylinder, we need to first of all draw a net. So a cylinder net is going to be a rectangle. That's going to give us a side surface, and then we have a circular top and a circular bottom. Okay, so there's going to be, we need to find out the area of the 3 surfaces, and we'll do the volume afterwards. So the surface area is going to be based on this 4 centimeter radius circle. I'm just going to shade that. Then we have 2 of those, so I'm just going to shade both of those in red. Okay, to find out the area of the circles, notice that I'm just trying to keep it all organized. It's going to be pi times r squared. And because we have two of them, we're going to multiply that all by 2. Okay, so it's going to be 2 times 16 pi, and that works out to be 32 pi centimeters squared. Okay, I'm just going to leave it like that for now. Then we need to find out the area of this rectangle. Now, the area of the rectangle is going to be based on the width and the height of that rectangle. Well, we know the height here is going to be 15. It's going to be 15 centimeters high. The width of this is going to be based on the circumference of the circle. So it's going to be 2 times pi times 4, which is equal to 8 pi. Okay, so that's going to give us that distance all the way across there. So then the area of that rectangle, which is a side surface, is going to be 8 pi, which is the width, times 15, which is the height, and that's going to give us 120 pi centimeters squared. Okay, so then working out the total area for this, if I add those two areas together, I'm going to end up with 152 pi centimeters squared. Working out the decimal value for this, 152 pi is 477.52 centimeters squared. So 477.52 centimeters squared. Now, when we're giving decimal values for these areas, either give me 1 or 2 decimal values of accuracy when you do the calculations. If you have errors, a little bit of error from rounding, that's okay. I will always be able to tell if the error is from rounding or if it's from miscalculation.